Good morning, students. Are you all happy and ready for today's class? All around us, there is chaos and confusion, but God has blessed us with yet another day. Let's be grateful and thankful to God. Put on a smile on your face and spread happiness to all around you. Let's move on to today's lesson, surface chemistry. We are going to learn all about catalyst in today's lesson. Let's see what is a catalyst. Let's see at the picture. I have two reactants, a red and a black. They need to combine to give me the product. They will do so at their own pace. But I want to alter the speed of the reaction. Then I add another substance which is yellow in color. Now this substance helps the reaction to take place and it does not take part in the reaction. Such a substance is called as a catalyst. It's just an intermediate. It helps the reaction to take place. Let's try to understand it with another example. We have nearly 75% of nitrogen in the atmosphere and hydrogen. They do not combine to give ammonia. Ammonia finds various applications in the industries, especially in the production of fertilizers for plants. But I need to take a catalyst ion. Only then nitrogen and hydrogen would combine to form ammonia. So we are going to define a catalyst. A catalyst is defined as a substance that alters the rate of the reaction but without taking part in the chemical reaction. Such a substance is called as a catalyst. Let's try to understand the characteristics of catalyst. What are the various characteristics of catalyst? A catalyst is needed in a small amount. A very small amount is enough. I may take large amount of reactant and product, but a catalyst is enough in a small amount. Remains unchanged. The catalyst does not go any change in mass, color, or chemical composition. It just remains unchanged. Whatever I take, I get back at the end of the reaction. It is regenerated back. It cannot initiate a reaction. I cannot start a reaction using a catalyst, but once the reaction is already happening, when I add a catalyst, it alters the rate of the reaction. Finely divided form, we have already seen. Instead of taking a lump of the catalyst, if I take it in a finely divided powdered form, the catalytic action is more. The increase in surface area increases the reaction rate. Equilibrium. What is an equilibrium reaction? When both the forward and the backward reaction take place at the same time, then it is called as equilibrium reaction. What happens when I add a catalyst to an equilibrium? It helps the equilibrium to attain at a quicker rate, at a faster rate, so that more products would be formed. It does not alter the nature of the products. If ammonia is a gas, even if I add ion, it will be NH3. It will be pungent smelling. And the amount of product depends upon the rate of the reaction, but otherwise the nature does not change. Effective at optimum temperature. For this Haber's process, when I use ammonia, it works very well at a temperature of 400 to 450 degrees Celsius. In Ostwald's process, when I use platinum in the manufacture of nitric acid, it works well at a temperature of 600 degrees Celsius. Temperatures above and less, the catalyst may be ineffective or the product may be less. Only at these temperatures it works effectively. So such conditions are called as optimum conditions. The pressure for Haber's process should be nearly 4 to 5 atmospheres. So these conditions where a catalyst works effectively is called as optimum conditions. Finally, they are specific in nature. As I was telling, Haber's process, I use iron as a catalyst. For Ostwald's process, we use platinum. I cannot interchange the catalyst. I cannot use platinum for Haber's process and iron for Ostwald's process. They are specific. They can react or facilitate only one reaction or certain reactions. I cannot interchange and take the catalyst. So these are the characteristics of catalyst. Let's move on to how the reaction takes place. The process by which a catalyst enhances a reaction is called as catalysis. There are different ways a catalyst can do. We are using the word only alter. Now let's see. Depending upon how it alters the reaction, we have different types of reaction catalysis. First one is positive catalysis. Only here we use increases the rate of the reaction. So when I add a catalyst, it increases speed of the reaction. Then I call it as positive catalysis. There are two types of positive catalysis: homogeneous catalysis and heterogeneous catalysis. What do you mean by homogeneous? The product, reactant, and the catalyst all are in the same phase. What do we mean by homogeneous? Homo means same, genus means phase. They all exist in a single phase, either solid, liquid, or gas. Then it is called as homogeneous catalysis. Just the opposite is heterogeneous. Different phases. The product and the reactant are in one phase. The catalyst is in another phase. Let's try to understand this with examples. Homogeneous catalysis. The example is formation of sulfur trioxide. Sulfur dioxide is a gas. Oxygen is a gas. The product sulfur trioxide is also a gas. And the catalyst which I take, nitric oxide, is also a gas. So reactant, product, catalyst, all three are in the same phase. So this is called as a homogeneous catalysis. Next we have hydrolysis of cane sugar. Here cane sugar is taken in a very dilute form. It is a liquid. Water is a liquid. Because it is in aqueous solution, the sucrose, the fructose and glucose formed are also in the aqueous solution. Everything is what? In the liquid phase. Sulfuric acid is a catalyst that is also in the liquid phase. So all of them are in the single phase liquid phase. Hence it is an example of homogeneous catalysis. Next, heterogeneous catalysis. As the name suggests, reactant and product are in one phase. Catalyst is in a different phase. Example, synthesis of ammonia. We've been seeing this continuously. Here, hydrogen and nitrogen are in the gaseous phase. Ammonia is also a gas. But what is the catalyst I take? Iron. It is a metal. So it is in the solid phase. The next example is decomposition of hydrogen peroxide. Hydrogen peroxide is a liquid gas. Water is a vapor and oxygen is a gas. But the catalyst which I use is platinum, which is in the solid phase. Continuously, we've been talking about contact chamber process or sulfur dioxide. Here, as you can see, sulfur dioxide is a gas, oxygen is a gas, product sulfur trioxide is a gas. But it takes place on platinum, which is a solid. So these are the examples of heterogeneous catalysis. Next, we are going to see another type of catalysis, negative catalysis. As the name suggests, the catalyst reduces the rate of the reaction. Instead of increasing, it decreases the speed of the reaction. Example, oxidation of chloroform. Here, if I have traces of ethanol, it reduces the rate of the reaction. The speed decreases. Such a catalyst is called as a negative catalyst. Another example, decomposition of hydrogen peroxide. Here, glycerol, even if traces of glycerol is present, instead of increasing the reaction, rate of the reaction, it decreases the rate of the reaction, acting as a negative catalyst. The next one we are going to see is autocatalysis. Here, initially, the reaction will be at a very slow rate. It will take place very slow. But after some time, I don't add any catalyst. But suddenly, I see that the reaction is faster. How? One of the product formed itself acts as a catalyst. Such type of action is called as autocatalysis. So, one of the product formed acts as the catalyst. Let's look at the examples. Ester hydrolysis in the presence of water. Ester decomposes to give acetic acid and ethanol, ethyl ethanoate. But initially I don't add any catalyst for this, but after some time the rate increases. Acetic acid formed acts as a catalyst. One of the product itself catalyzes the reaction. Such a reaction is called as autocatalysis. One more example, decomposition of arsenious hydride. Arsenious formed catalyzes the reaction and acts as an autocatalyst. So we have seen the different types of catalysis. Next we are going to see two more concepts. Promoters. already have a catalyst. I want the catalyst to function better. For that, I need to add an extra substance. That substance which makes the catalyst to work efficiently is called as a promoter. Let's take again the example of Haber's process. By now you know that iron is a catalyst. When I have traces of molybdenum added to iron, iron works efficiently. So here molybdenum is my promoter. Next one. So when I have traces of molybdenum, it enhances the catalytic activity of iron. The next we have catalytic poison. For the same Haber's process, we saw that molybdenum increases the activity of catalyst. If any substance decreases and destroys the catalytic activity, then it is said to be a catalytic poison. Traces of hydrogen sulfide. If I find little bit of hydrogen sulfide in Haber's process, then iron does not function effectively. So hydrogen sulfide is a poison for iron in the Haber's process. Similarly, in the contact chamber process, when we saw sulfur dioxide and combining with oxygen to give sulfur trioxide, if I have traces of arsenic oxide, platinum does not function as an effective catalyst. So we can say arsenic oxide acts as a poison for platinum. That is why we don't use platinum nowadays, but instead vanadium pentoxide is used as an effective catalyst in contact chamber process. Children, today we saw all theoretical concepts. It's a very easy lesson, but every method or everything may be a 2-mark or a 3-mark question, and characteristics of catalyst will be a 5-mark question. Let's quickly recall what we learned. We learned about a catalyst, a substance that enhances the rate of the reaction. We saw the catalyst. Small amount is needed, cannot initiate the reaction, remains unchanged, helps at equilibrium to attain at a faster rate, works effectively in optimum condition, finely divided condition, and then it's very, very specific. We saw catalysis. The process by which a catalyst works is called as catalysis. The different types we saw: homogeneous catalysis, heterogeneous. The catalyst and the products reactant in the same phase is called as what? Homogeneous catalysis. When the reactant and the product are in the same phase, catalyst in a different phase, then it is called as heterogeneous catalysis. What is negative catalysis? Instead of increasing the rate of the reaction, it decreases the rate of the reaction. Then it is called as negative catalysis. What is autocatalysis? I don't add any catalyst. Suddenly the rate of the reaction increases on its own. One of the product form acts as the catalyst. What are promoters? Help the catalyst to be more effective. Sorry, we did not say active centers, but we saw what is called as catalytic poison. As I told you, children, today's lesson is very simple. Please keep revising, read through the lesson given in the PDF link and take up the Kahoot. But learn every question which we learned today as a 2-mark or a 3-mark with examples and the correct formula. Stay home and be safe, children. Take care. Thank you.